PD that I got here. 28 equals to what? 60. And A is equal to what? 60 minus 28. A is equals to 20, is it 24? 32. Abi? Yeah, 32. So that's my A. Do you understand, please? Okay. So when next time we meeting again? Tomorrow or midnight? Midnight. Midnight. What happened that I've not gone home since Kiningo? Eh? I say where to stay. What if I tell you that I've been standing since Kiningo? Geometric progression. So now, unlike arithmetic progression, which is more of your addition and your subtraction and all of those kind of stuff, your geometric progression works more with multiplication and division. I get what I'm trying to say like that. Okay, I'm blocking it. Sorry. I don't know, where should I now stand? Okay, I'll stand in the middle here. I don't think I'm blocking anyone like this. Am I blocking anyone? Your geometric progression is more of like multiplication and what? And division. I will see if we can have examples, probably. Let me see. We can have probably 3 or 4 examples. Who gave me this textbook? Okay. So as we understood how to create terms in our AP, let's also work on how to create terms with our what? With our GP. Are we done writing that side, please? Please just write fast now. Okay, I can use this part. Okay. Let's write fast. Although I'm waiting for you in the midnight, yeah? It's 9. Okay, I'm waiting for you by 9. I should not wait for you again. Eh? You will not want to miss the 9th class, huh? So, okay. So let's work on some few terms here. Let's work on some few terms so that we can probably be able to generate what it looks like. So from there, what do I have? So I have you have Tn is equals to what? Arn minus 1. And from here, when you're T1, that's when n equals to 1. What do I have here? Ar1 minus 1, which will give me what? Ar0, which is the same thing as what? A. Then T2, which is what? Ar2 minus 1, which is the same thing as what? Ar1, which is what? Ar. Then what will T3 be? That would be what? Ar3 minus 1, which is equals to what? Ar squared to be what? Yeah, Ar squared. Then T4 can be what? Ar cubed. T5 will be what? Ar what? Is power 4. So these are all the terms that we can form from what? Our normal GP. And unlike your AP, where your common difference is either is formed from subtraction, your common ratio here is formed by what? By division. I guess I'm trying to say like that. And this one here is the sum of your nth term. Although there are two conditions here. The first condition is when your R is what? Greater than 1. You have this formula. Second condition is when your R is what? Lesser than 1. You have this formula. And last one here you have is what? Is your sum to what? Infinity, which is what? A divided by 1 minus what? Minus R. Let's look at probably one or two examples from your manual. Two examples from your manual. Okay, I'm ready to write. Number 1. When's this manual? Okay. Number 1. Find 3 numbers in geometric progression. Find 3 numbers in geometric progression. Find 3 numbers in geometric progression. Are we there? Find 3 numbers in what? Geometric progression. Whose sum is 10 and a half? Whose sum is what? 10 and a half. And product is what? 27. Whose sum is what? 10 and a half. And product is what? 27. Okay, let's look at that question quickly. Now if you take a look at that question, can I clean on this part? This part here. You know that I explained to you that you can adjust your arithmetic progression to the back. Yes or no? The same way you can adjust your arithmetic progression to the back, the same way you can adjust your what? Geometric progression to the what? To the back. I guess what I'm trying to say like that. Now, if I want to adjust my geometric progression to the back, so that means I can have, instead for me to have AR and what? AR squared. If I adjust these two to the back, then I can have what? A by R, yes or no? Then I have what? A and I have what? AR. Because by the time I divide everything here, my common ratio will still be the same thing. I mean now, or multiply everything here by your common ratio, you still have what? What you still have on top here. Are we together? So whatever I just did here was that I shifted all of this term back how many times? Just once. I will get what I'm trying to say like that. So now if you now observe the question said that the sum of these 3 numbers is what? A over R plus A plus AR is what? What is the sum? 10 and a half. And their product, which is A over R multiplied by A multiplied by what? AR is equals to what? 27. So now the reason why is that if to say I was using this one here, I will not be able to, by the time I will be multiplying here, I will not have any term to what? To cancel out, and it will elongate my what? My problem. I guess what I'm trying to say like that. So from here, I can now have R here to cancel this R. Now I'll be left with what? A times A, which will give me what? A cube, which is what? 27. And if I take the cube root of both sides, I can say that A here is equals to what? 3. So if A is equals to 3, what can I do? Substitute A back inside this place to get your what? To get your R. Then I can now have 3 over R plus 3 plus 3R equals to what? This 10 and a half is the same thing as what? 21 over 2. Yes or no? Then from here, let's say I multiply everything by what? By 2R. Are we together? So multiply everything here by 2R. What will I have? I will have, is it 6? By 2R. And I have 6 plus, what do I have here? 6R plus 2R times this will give me what? 6R squared equals to what? 21R. Yes or no? I be now. Multiply everything by 6R. So from here, what is common here? I know 6 cannot go in 21. It's 3. So if I reduce everything by 3, what will I have? 2 plus 2R plus 2R squared equals to what? 7R. Take this one to the other side. Then you can now have, what can you have? And have 2r squared, all together. 7r minus this will give us minus 5r. Then what do I have here? Is it minus 2 or plus 2? Plus 2 equals to what? 0. Yes or no? Then by expanding or factorizing, so I have what? 2r squared minus 4r minus r plus 2 is equals to what? 0. By factorization, what's common here? 2r, and that will give you what? R minus 2 minus what? 1, which is what? R minus 2 equals to what? 0. And from here you have what? 2r minus 1, r minus 2 equals to what? 0. Then you can either say that r is equals to what? 1 over 2, or r is equals to what? 2. So now, since I have two values for r here, that means for my numbers here, how many values of numbers will I have? I will have two values. I get on a plan to say like that. So I can say that here, the numbers when r equals to 2 is, so if my r is equals to 2, what will be my a? My a is what? 3 over 2, are we together? Minus 3 times 2 is what? 6. This is the numbers when I have r equals to 2. Now again, the same numbers when r equals to what? Half. Then what do I have here? I have what? 3 divided by what? Half. And I hope you know that 3 divided by half is the same thing as what? 6. What is my a here? 3. And what do I have here? AR. And what is AR? AR is what? 6 multiplied by, is it 6 now? 3 multiplied by what? Half. And at the end of the day, what do I have here? 3 over what? 2. Have you now? So which is the same thing that I get here, although the order is what? The order is different. So I can say that the three numbers that I'm adding together is what? 3 and 3 over 2, 3 and what? 6. And the three numbers that I'm multiplying together to give me whatever down size, which is 27, is what? This number. Do you understand, please? Are you sure? Do you understand? Okay. One over 2. I changed this one here to improper fraction. 2 times 10 is 20 plus 1, 21 over 2. And I multiply, yes sir? Yeah, this is your original term, and I told you that I just did what? I adjusted this term what? To the back. Just as I did for my AP. You know my AP was A plus D, A plus 2D. And what happened when I adjusted everything by D? I had A minus D, A and what? A plus D. Same thing happened here. I adjusted all of this one to the back to give me what? This. And the reason why I'm adjusting all of this is because if I don't adjust this one here, I would not end up having any terms here to be cancelled out. I guess I'm trying to say like that, and to make my work with them to the back. Any other questions that I would love to ask? Please ask your question too. Any other questions? Yes? Sir? Did you question about this? Now the thing is that I was trying to show you what you were supposed to use. But I was now saying that if you use these terms, you will get the answer. But it should just take a what? A longer process. So a way to avoid the longer process is by reducing this term, by just reducing them by 1. Taking them back to the, taking question here. I get one point like that. So this is the question, this from this one here, that I got this one. You get one point like that. Any other questions again? This number, I think that's question, what is that? Question 9, yes. That's question 9. I think your manual, we did question 9 today. We did question We did question 6, we did question 4. Next question, we did question 17, and we did question 25 and 28, which actually is the same thing, but they repeated by what? By typo. Any other questions, please? The next time that we'll be meeting, this is what will happen. Let's sketch the map. So the map of what will happen when next we'll deal with more questions on sequence and series. Then we'll embark on the journey of what? Quadratic equation. We solve as many as we can solve. Then by God's grace, we should be able to finish quadratic equation. We should. Next time we meet. I have not said you should start clapping now. Why are you clapping now? People are still writing now. And I'm still waiting for questions. If you have questions, ask, please. Yes, ma'am. Ma? Question 7 in your manual. Okay, let me see question 7. I think I still have 4 minutes to spare. Which of the manuals is it? Like which page? Okay, question 7. I think I treated question 7 with him earlier on, where I was drawing some stuff on the board. Abi now? You wrote it down now. It's with him. You can come check it. Question what? 23. No idea. Can I what? This one here. This one here. Huh? Yeah?
Yes.
How did I get it?
Yes.
This is where I got it from now. I had 2R, I had 2R squared, and I had 7R. Then we bring this 7R to the other side. And now becomes negative 7R. And that negative 7R, we compute everything together to give me what? This quadratic equation. I moved only this one to this side. No, I didn't carry anything on this side. Do you understand? So initially here, this one was what? 2R squared. Then if I brought this 7R to the other side, it should have become 2R minus what? 7R, which will give me what? Minus 5R. Then this 2 that is here is still the same 2 that is there. Abi now? You get now? Then what I did here was just normal factorization. Abi? Okay, so that's good. So, I have said, you can try your best. Next time we meet, I've not asked you to start going home now. I'm gonna calm down now. Some people are still writing. What you guys want? What do you want to do at home, say? Lazy people. Lazy people. I want to go and eat. As you go and eat. So I'm waiting. No, I think no other questions that we have to ask. As I've said, please, next time we meet, any on the level that be around, please just tell them we are likely to meet this midnight or this night. I don't know when, but we are supposed to meet one more time again. I think more than one more time, actually. One more, so we are supposed to meet. So as you are meeting, please come with your manual. If you have any past questions that you have around, come with them and let's solve them together. Are we together, please? So come with them and let's solve them together. So I think today we did a lot of questionings, and there was one question I wanted to take up. I wanted to fuck up, but we later treated it. Glory to God. Although we canceled a lot of books and I cleaned a lot of board, but at the end of the day we got the answer. Have you now? So thank you very much. I love you all. So. Next set of students, please. You're welcome. Boss man. Away. Yes, MTS 2-1. Oh yeah. Sit down, sit down, quick, sit down briefly. Is it 2-1 or 2-5? 2-1. It's 2-9 now. Yeah, 2-9, sit down then. Abi? Okay, so one you saw. Which one? Okay. Yes. I just. Which one am I agreeing to do now?
205315209.
Okay. Okay, it's 2-5. According to that, will be 2-5. Sorry. So 2-5, 2-9, and 3-1-5. The same thing. Okay, let's sit down. So where do we stop? The other time we met, we stopped at yes. And this time, that time we were not able to discuss exact differential equation. We'll talk about it later. Sorry. We're not able to discuss exact differential equations well. I think we did only one example and we ran away. So let's do probably 2 or 3 so that we can master it. So 205, 209, 315, still the same thing. All right. So still talking about exact now. Still on exact differential equations. Number 1, let's see. We had y squared minus x squared dx plus 2xy dy equals to what? 0. So continuing from where we stopped the other time. So don't forget we're on what? We're on exact. So we're on exact. Okay. So we're on exact. So now, and I told us that how do we do? What is the first thing that we do on exact? The first thing that we do on exact is that we check for what? We check for exactness. Are we together? So let's check for exactness here. And how do we check for exactness? We say that partial m, partial what? Y must be given what? Partial n, partial what? X. Yes or no? Then from here, what is the thing we have to look for here? We have to first of all look for, let's know our m. So in this case, what is my m here? My m is what? Y squared minus what? X squared. And my n here is what? 2xy. So since this is it, so let's now differentiate. Partial m, partial y. What would this one give me? 2y. Then partial n, partial x. What would this give me? 2y. Yes or no? So since both of them is giving me the same thing, so that means this equation that I'm dealing with is what? Is exact. Yes or no? Now since this equation is exact, so how do we solve? first thing that we have to do is what? We have to integrate m with respect to what? X. Then, so let's integrate here. So by integrating m respect to x, what do I have here? Y squared minus what? X squared. Everything here dx. And don't forget that when I'm integrating, what do I have as a constant? I have my y to be what? A constant. So by integrating this, I have what? X y squared minus, if I integrate this one, what would I have here? X cubed divided by what? 3. Now, number 2 says that you should integrate n with respect to what? To y. All terms that does not contain x. Then if you look here, you find out that n has only one term, and that term itself that it has what? It has what? It has x. So that means in this part, my answer here is what? 0. Number 3, which will be the solution. So answer 1 plus what? Answer 2. This will give me what? My constant. What's my answer 1? My answer 1 is what? Xy squared minus what? X cubed over 3. I think plus 0 equals to c. And I can erase all of this one to say that this is my what? This is my final answer. Do we get? Do we get? Okay. So now another one. Y 6 squared x plus sec x and x dx. Then x plus 4 y. So this, we have this exactness. So now from this exactness that we have, so let's now start testing it one by one. So first thing that you have to know is what is your m here? Your m here is what? Y sec x plus what do I have here? Sec x tan x. Are we together? And what is my n here? My n is what? Tan x plus what? 2y. Then for test of exactness, what must happen? Partial m partial y must be equal to what? Partial n partial what? Partial x. So let's test for that. So what is partial m partial y? So partial m partial y, what would that give me? So that means I'll differentiate here the only thing that has y, which is what? This one. So if I differentiate this answer, what will I have here? I will have what? Sec squared x. Yes or no? Now the other one here, which is what? Partial n partial what? X. If I differentiate this one, what do I have here? Sec squared what? Sec squared x, which is the same thing. Now let's now start writing the solution. What is answer number 1? Integration of what? M with respect to what? X, keeping y as what? Constant. So from here, if I integrate y sec squared x plus what? Sec x tan x, everything here dx. So what will be my solution here? If I integrate y sec, so if I integrate sec squared, what will I have here? Tan x. Plus if I integrate sec x tan x, what will I have here? Sec x. Abi now? Now the other one is integrate what? N with respect to what? To y. All terms that do not contain what? X. I think this is the only term that doesn't contain x. So if I integrate 2y dy, what will be my answer here? 2y squared over 2 to give you what? Y squared. Then final answer, answer 1 plus what? Answer 2. Everything should give me what? My constant. So what's answer 1? Y tan x plus what? Sec x, are we together? Plus what? Y squared equals to what? C. Do we get, please? Do we get? Okay. Let's look at 2 more examples, or 3. How many examples should we look at? All right. Now let's look at this question. I love this question. I want it her. Is it your love? Eh? The person I said her, is it your love? I cannot love again in peace, innit? Now, let's look at this now. So as usual, first thing first, let's find out our m and our n. Are still writing this one? Eh? Wanna write fast now? So m here, what is your m here? What is m here? That is ax plus hy plus g. And your n here is what? hx plus by plus f. Now, partial m, partial y. What would that give me? Abinam. Partial n, partial x. What would that give me to? H. So now, answer number 1. Equation of m with respect to x. So what do I have? I want to integrate ax plus what? Hy plus g. Everything with respect to what? Dx. At the end of the day, we have what? Ax squared divided by 2 plus hxy plus what? Gx. Yes or no? And number 2, integration of what? N respect to what? Y. All terms without x. So which one will I be integrating here? by plus what? Plus f dy. So if I integrate them, what do I have? I have by squared over 2 plus what? Fy. So what is my final answer here? Add these two together. You can have ax squared over 2 plus hxy plus what? Gx plus what? By squared over 2 plus what? Fy equals to what? 0. And that's the answer. So now one more before we look at inexact. So we have this. Now this time around, it's going to look a little bit somehow. So now first thing first, let's start labeling. So what is my m here? My m is what? X cubed minus what? 3xy squared. What is my partial m, partial y? What do I have here? Minus 6xy. Then what is my n in this case here? Y cubed minus what? 3x squared y. Then what is partial n, partial what? X. That is what? Minus 6xy. Then solution number 1. I have what? Integration of what? X cubed minus 3xy squared dx, which is the same thing as x to the power of 4 over 4 minus what? 3x squared over 2y squared. Abi now? Please, are we together? Okay. And the second one, I want to integrate. What am I integrating there? Y cube. So if I integrate y cube, what do I have? Y raised to the power 4 over what? Over 4. Now what will be my answer? My answer will now be x to the power of 4 over 4 minus 3x squared y squared over 2 plus y to the power of 4 over 4 equals to what? Equals to what? C. I could have left my answer like this, but what happened here? I have a condition. And what is that condition saying? As is y of 0 equals to what? 1, meaning that y is equals to what? 1 when x is equals to what? 0. So from there, I can have, yeah. So from here, y of 0 equals to 1. So that means, so x is equals to what? 0 over 4 minus what? 3, 0 over what? 1 squared over 2 plus 1 raised to the power 4 over what? 4 equals to C. And I can say that my C categorically equals to what? 1 over 4. Then put that answer back here. Then what do I have here? I have x to the power of 4 minus 3 x squared y squared over 2 plus y raised to the power 4 over 4 equals to what? 1 over 4. And from here, what can I multiply everything with? I can multiply everything here with 4. So multiplying everything here with 4, what will I have? I will have x raised to the power 4 minus 3x squared y squared, not 3 now, minus 6. Then what do I have here? Plus y raised to the power what? 4 equals to what? 1. So that's the answer. So next time I want to look at now. So inexact. So inexact differential equations. Okay. So the next one I want to look at here is inexact. There are rules guiding it. Rule number 1. If partial m partial y minus partial n partial x over n is a function of x alone, then multiply through by integrating factor exponential f of x dx. Number 2, if partial n partial x minus partial m partial y divided by m is a function of y alone, then multiply through by integrating factor There are about like about like 4 reasons. So let's start taking the reasons. Let's start taking the reasons then one by one. Okay, let's. Okay, don't have space there. Okay, don't. Can I clean this part? Okay, good. Okay, let's look at this question. So now, first thing I wanted to look at is that I want to observe the way this equation is written. This equation is not written in the normal way it should be written. Are we now? Because a normal exact differential equation should be written in what? M dx. M dx plus what? N dy. What this one? This one is written in terms of what? This one is written in terms of what? M dy plus what? N dx. Now, first of all, is that you have to what? Rearrange it. Rearranging means you just have to what? Swap both sides. Are we together? Now, let's swap. So I can have 2y dx plus what? 2x ln x minus xy dy. Are we together? Sorry, this is what? This is dx and this is dy equals to 0. Now I want to test whether it's exact or non-exact. Obviously, from the way it looks like, I hope you know that it's already obvious that it's non-exact. I want to argue with it again. Let's argue. Partial m. First of all, what is my m now? My m is what? 2y. My n is what? 2x ln x minus what? xy. Now partial m, partial y should give me 2. And partial n, partial x here should give me 2 also, but unfortunately I cannot have 2 here. If I multiply this one, I think I'll be having 2 plus